Hi, I'm Ben, and today we're working on inverse functions and their representations. Our objectives today are to look at inverse operations, look at one-to-one functions, and then look at symbolic representations of inverse functions. And lastly, we're going to look at other representations of inverse functions. So for each of the following, state the inverse actions or operations. Put on a coat and go outside. Well, we want to invert this. So instead of go outside, let's come inside. And then instead of putting on a coat, let's take off the coat. So the inverse of put on a coat and go outside is come inside and take off the coat. So what we've done is we've taken the end and put it at the beginning and inverted it. So go outside becomes come inside. The end is at the beginning. We work our way from right to left, and then put on a coat becomes take off the coat. So that's something that makes sense in words. How about with math? Subtract 7 from x and divide the result by 2. Well, that's like x minus 7 over 2. The inverse of that is to start with 2, and instead of dividing, we do the inverse of that, which is multiply, times x, and then instead of subtracting 7, we add 7. So the inverse of x minus 7 over 2 is 2 times x plus 7. Now, one type of function that's very interesting to us is what's called a one-to-one function. A function f is a one-to-one function if for elements c and d in the domain of f, c not equal to d implies that f of c is not equal to f of d. That is, different inputs always result in different outputs. The key is always. It's not just any two. Every two has to give you a different outcome. So let's use the graph of f here to determine if f is one-to-one. Specifically, what we use is the horizontal line test. Remember, the vertical line test tells us whether or not it's a function. If you draw a vertical line anywhere through here, it'll only cross this shape once, so we know it's a function. But if it's a one-to-one function, it will also pass the horizontal line test. The horizontal line test means that each y value is only derived from one x value. So every horizontal line through here should only cross the figure once. And in fact, this case, that is true. So this is a one-to-one function. Let's look at another graph. B here passes the vertical line test. We can draw vertical lines all the way through here, so we know it's a function. But we can take a horizontal line here, say y equals 2, and it crosses the figure at 2 points. It doesn't pass the horizontal line test. So this is not a one-to-one function. So the way that these examples were shown, we used what's called the horizontal line test to show whether or not they were one-to-one. The horizontal line test simply states that if every horizontal line intersects the graph of a function f at most once, then f is a one-to-one function. So we're also interested in inverse functions. One-to-one functions have inverses. And here's what an inverse function looks like. Let f be a one-to-one function, then f inverse is the inverse function of f. If f inverse dot f of x is equal to f inverse of f of x, that's equal to x. For every x in the domain of f, and f dot f inverse of x is equal to f of f inverse of x is equal to x, for every x in the domain of f inverse. So let's see if we can find a symbolic representation of f inverse. To find the formula for f inverse, perform the following steps. Verify first that f is a one-to-one function, and then solve the equation y equals f of x for x. And that results in the equation x equals f inverse of y. So step 3 then is to interchange x and y to obtain y is equal to f inverse of x. And then to verify f inverse of x, show that f inverse dot f of x is equal to x, and that f of f inverse of x is x also. So let's find an actual inverse. Find the symbolic representation for f inverse of x when f of x is 2x cubed minus 5. Well, the first thing we want to do is graph the function. If we graph the function, you get something that looks like this. You can look at this and see that it's one-to-one. It passes the horizontal line test. So we should be able to find an inverse. How do we find an inverse? Well, let's start by writing this as y is equal to 2x cubed minus 5. And then let's solve for x. So y plus 5 is equal to 2x cubed. Divide both sides by 2, so we get y plus 5 over 2 is equal to x cubed. And then we want to take the cubed root, so we get y plus 5 over 2 cubed root is equal to x. Now we just switch x and y. So we're going to say that y is equal to the cubed root of x plus 5 over 2. So this is f inverse of x. Now how do we check this? We're going to take f of f inverse of x. So remember, f inverse of x is the cubed root of x plus 5 over 2. So we're interested in f of the cubed root of x plus 5 over 2. And so remember, f of x is simply 2x cubed minus 5. So 2 times cubed root of x plus 5 over 2. This is cubed minus 5. Well, the cubed root raised to the third power, the cubed root cubed, is just 1. So this is going to turn into 2 times x plus 5 over 2 minus 5. The 2's cancel, and so we have x plus 5 minus 5, so the 5's cancel, and we're left with x. So f of f inverse of x is equal to x, and it works. So let's try another problem. Find the symbolic representation for f inverse of x when f of x is equal to negative 2x plus 10. So go ahead and hit pause and try this one on your own. Then come back and we'll do it together. All right. The first thing we need to do is check the graph and make sure that this is a one-to-one function. So when you graph it on your calculator, you come up with something like this. This looks like it's going to pass the horizontal line test pretty easily. So this function is one-to-one. How do we find the inverse? Well, we go ahead and rewrite it as y is equal to negative 2x plus 10. Now we solve for x. Y minus 10 is equal to negative 2x. So y minus 10 over negative 2 is equal to x. From here, we just switch out x and y. So we're going to say that y is equal to x minus 10 over negative 2. Or if you want, you can write it as 10 minus x over 2. Whether or not you like having a negative sign in the denominator is up to you. So let's see if this works. We need to check it. Remember, we want to see if f of f inverse of x is equal to x. So remember, this is what we came up with for f inverse of x. And so let's take f of x minus 10 over negative 2 and see what we come up with. Well, f of x is negative 2x plus 10, so this should be equal to negative 2 times x minus 10 over negative 2 plus 10. The negative 2's cancel, so we have x minus 10 plus 10, so the 10's cancel, and we're left with just x. So sure enough, f of f inverse of x is equal to x. So let's take a look at a related concept. Domains and ranges of inverse functions. The domain of f is equal to the range of f inverse, and the range of f is equal to the domain of f inverse. So what does this mean for the graphs of their functions and their inverses? The graph of f inverse is a reflection of the graph of f across the line y equals x. That's this line right here. So we just reflect whatever function we have across that line. So let's use f of x to complete a table for f inverse of x. If f inverse of x here is this line, and x is negative 3, 0, 3, and 6, f of x is equal to x plus 5. So how do we solve for the inverses? Well, remember it's y is equal to x plus 5. So let's solve for x. We get x is equal to y minus 5. Now switch around the x's and the y's, and you get y is equal to x minus 5. So we can go ahead and plug in the values here. When x is negative 3, the inverse, negative 3 minus 5, negative 8. When x is 0, 0 minus 5, negative 5. When x is 3, 3 minus 5, negative 2. And when x is 6, 6 minus 5 is 1. Now let's look at a graph and see how we can use graphs to sketch inverses. So use the graph of f to sketch the graph of f inverse. Well, here we have the graph of some function f. It's a linear function that connects the points negative 2, comma negative 4 to the point 1, comma 2. What we need to do is flip it over the line y is equal to x. That's this line right here. So when we invert it across this line, we're going to come up to the points 2, comma 1 and negative 4, comma negative 2. So 1, 2, 3, 4, 1, 2 right here. So we've switched out the 1 and 2 and made it 2, 1, and the negative 2, negative 4, and made it negative 4, negative 2. So we got these 2 points. Now we need to connect those dots. So the red line here is the inverse function. This is f inverse. And this here, the black line, is f of x. So today, we worked on inverse functions. Looked at one-to-one functions, and there are a lot of problems like these in your book. So give those a try before you come back next time and we do a new section.